conference will now be recorded.
Good morning, everyone. Screen and audio both are fine or not, please confirm. Screen and audio both are fine or not, please confirm. Okay, thank you. Okay, I think screen and audio both are fine. So I got the response. So we'll start the demo session on physical design. So the course structure which we are going to follow here in physical design, I'll discuss that first before we start on the demo session. So the course structure, so what we are going to cover here. So I will tell you the course structure first and what are all syllabus or the topics which is going to be covered in this session, and how placement support and interview preparation support will be given to you. And then we will discuss few topics related to physical design. We will also see PD flow, right? I mean, we will see the SIG flow also as well as PD flow. And we will see that what are all advanced design concepts which is going to be discussed in the advanced physical design course. And then, so what happens in the final sign off or tape out process. So in this way, we will follow. So this course, physical design course structure is for 6 months, at least for 6 months, in which the first part or the first phase will be for 2.5 months. That is allotted for the basics. I will tell you that what is all topics which is going to be covered in basics. So PD basics will be covered for 2.5 months. Then comes next 4 months. So the dedicated 4 months is only for physical design, advanced level concept. Right? It won't be the basic level. So it will be purely related and dedicated to physical design concept, which will be for 4 months. So yeah, so the first phase will be for PD basics. In PD basics, that is for 2 to 2.5 months approximately. So the topics which we are going to cover here is, first is digital basics, GVIM basics, then Unix and Unix Linux command, because industry works whatever design we are following, right? Whatever design we are doing. So you go in any company. So industry works in the Unix or Linux based platform. That is why those commands you should be knowing, right? Then tickle basics is also important. So as a fresher, if you are joining as a fresher, so little bit knowledge of tickle will give you some advantage. CMOS basics are must, and the physical design basics, right? If you cover these basic topics, so definitely your basic part will be covered and you will be eligible for the PD advanced topic. Okay. What are the class timings? So when these classes will be conducted? So for weekdays, it will be Monday to Saturday, and for weekends, it will be Saturday on Sunday. Now there are, so weekends, Saturday and Sunday means not for everyone. So for Saturday, Sunday weekend batch means those people who are attending in hybrid mode or online mode. They are not able to come to institute due to reason, or they might be working in some company already in some IT sector or some different branch, or okay. So they don't have time to come, or they are living in some other state and they are not willing to relocate to Bangalore. So for these people, we have weekend batch. Okay, all these basic sessions will be recorded live in the live session, and all these pre-recorded videos will be uploaded in the same day itself, so that you can rewatch it if you have missed any topic or understanding on any concept. Clear, everyone? Any doubt? Any question here? So this is about PD basics, which we will follow for 2 to 2.5 months. So we don't have to cover all the basic part which we are learning. So just let me. So so if you have completed your BTech, right? So you might have studied lot of subject. We don't have to go through all those subject. So important subject here which needs to be covered as a part of basics is digital, right? Digital system design, and second one is CMOS. So if you cover these two, right? If you cover these two, this is more than sufficient to start with physical design. So this is the basic concept which will be required, or I will say prerequisite subject, right? This should be very clear. So those who are attending this session, can I have the response, like how many students are there who have completed their BTech, or they are in final year BTech, or they are in MTech final year or completed MTech? or you are in PhD? Can I have the response, like how many are there who are from BTech background, MTech background, or PhD background? Yes. So there is a chat box. If you see in this online session, on right side we have a chat box. You can speak out or you can write it in that chat box also, your responses. Okay. Dikshit, I am in final year batch. Okay. What about others? See, if you respond, this will help us to module the course structure according to that.
Hi, I am Satya.
Okay. Hello.
I'm completed BTech. I passed in 2018. I am working on front end design, UA developer
Okay. You
right
are
now.
already working in front end RTL designer.
No, web design side actually, IT.
Oh, okay, okay. So it is software, right?
Yeah. Uh,
Okay.
so I want to shift this core level job. So that's why I
Hmm.
choose this course. I
Okay.
am
It's
2018 batch. 2018 batch. I passed out.
okay, okay. So yeah, I'll come to that point also. So I'm just
Yeah.
understanding the background of people who are attending this session. BTech working in IT. I have completed my BTech in 2023. I am in third year, B final year. Okay. So we have. So there is no one from MTech or PhD. All are from BTech pass out or BTech background or IT background. Anyone from the MTech background? No, I guess. Right? Okay. Okay. So we got the responses. Now the next phase, that will be for 4 months, right? So in these 4 months, which is completely dedicated to the physical design topic, right? Now, what is the benefit of attending PD advanced session followed by basic session? See, many of you are from IT background, right? You might have um, you need to revise the basic subjects, right? Because there is a long gap. Now you are working in IT sector for 1 year, 2 year, or 3 years. So that education touch is gone, right? You might have forgot a lot of basic topics also. So that is the reason for first 2 months or 2.5 months is given for basics. So this will also help the students who are there in final year, right? Because you have studied digital and CMOS maybe in second year or third year, right? So this will help you to revise topic and understand which topic we are covering in digital and CMOS, which will be helpful in your understanding advanced physical design topics, right? Because PD advanced is part of VLSI, it is not the VLSI. So ASIC VLSI is very huge, it is kind of ocean, right? And we cannot directly introduce you to the physical design. For that we need to build some foundation for you to understand what is going on in VLSI, right? That is the reason basic part is given, which is helpful for everyone who wants to join in VLSI design as a fresher. But those people who are already experienced in VLSI, for them maybe basic part is not that much required. You can directly join PD advanced session. If only if you are experienced in VLSI, some other domain or something. So in that case, you can skip the basic part. Otherwise, you should attend the basic also. So in phase two, it will be consisting for 4 months. We will have PD advanced session. In that, we will give you both theoretical sessions as well as lab session, right? So lab session will be conducted on the weekdays from Monday to Thursday. We will have one dedicated live project on 28 nanometer, on 14 nanometer. Now, and currently, recently, we also got the project on 5 nanometer also. So the setup is going on. It is not started yet, but we got the project on 5 nanometer also. That is what I am having the information. Now, the weekday session will start from 10 a.m. to 1 p.m. and there is also second slot. So that is 2 p.m. to 5 p.m. Based upon the students' responses, the slots can be changed from morning or afternoon in weekdays. Where in these weekdays you will have dedicated lab session. Now, what we are going to have in the lab session? So those lab sessions are dedicated for practicing the practicing or working on the design, right, in that project, using what, using EDA tools. Now, what is EDA tool? So if I say EDA tool, what you understand from EDA tool? Anyone? What is EDA tool? Anyone? EDA tool, no one knows. So it is electronics design automation tool. Now, whatever design we are working on, right, when we say design, so whether it is a software design or a hardware design, which one is true? Is it a software design or a hardware design? Yes, it is a hardware design, right? It is not a software design because, so I'll discuss more on that when we start the VLSI. So the EDA tools are very important here. So why I will tell you why EDA tools are very important here. Now, when we say VLSI, what does VLSI stands for? And what is VLSI? So you are going to opt for this course, right? You should at least know what is VLSI. Yes, people who are attending this session, what is VLSI? Okay, very large scale integration. Anything else? Is it just, it is the just full form, right? You need to explain more. When we say a VLSI design, what does VLSI design means? What it has? So you are choosing VLSI on basis of what? If you do not know the VLSI, right? You should be knowing what is VLSI, right? At least I'm not expecting to know everything about VLSI. But what happens in VLSI, at least you should be clear to that, right? Before choosing this course. Placing billions of transistors on single IC. Okay. So somewhat correct what Bhargav has told, right? So it is what? Integration of millions of billions, right? Integrating billions of transistor on what? On silicon chip, or I'll say silicon wafer. Then it is cut into multiple number of chips. right? Now when we say the silicon wafer, what does silicon wafer means? So VLSI design is part of semiconductor industry. Right? What is semiconductor? So how many types of semiconductor is there? How many types of semiconductor is there? See, these are very basic thing. How many semiconductors are there? Simple question. Two types. What are those? What are two types of semiconductor? I mean, what are the semiconductors available? Silicon and germanium. You have forgot all these. So there are basically two semiconductors available, silicon and germanium. Which one is better, silicon or germanium? Silicon is better. Why, Bhargav? Why silicon is better? See, the better one is germanium, right? Right? Better one is germanium, not silicon, because it has, so it conducts faster compared to the silicon, right? And it conducts faster compared to the silicon. So, but why we choose silicon? Why not germanium? Yes, germanium is also chosen for specific application, for not for the commercial application. But why silicon is chosen? Because it is abundant in nature, right? The availability is very high. Why? Why I am saying that silicon availability is high? What is the source of silicon? What is the source of silicon? Sand. That's correct. Right? Now, if you see in nature, right, it is abundant in nature, free of cost. That is the reason. So it reduces the overall cost of chip making. So sand is taken, right? It is abundant in nature. Then it is melted, right? And melted, and silicon is extracted, and it is created something like this, right? Some structure, cylindrical structure, something like this. Now this cylindrical structure, a big cylindrical structure, is called as ingot, silicon ingot. Right, now what happens, we take this silicon ingot and slice it, right? Laser cut slicing happens, right? And sliced into what? Wafers, right? Circular, right? So I'm drawing a 3D here. So it is basically complete circular silicon wafer. What is wafer? Now you take a potato, right? Have you seen potato? You take a potato, wash it, and then slice it, right? You have seen? Slice it, and then deep fry into what? Oil. Take some oil and deep fry it. Now what you will get? What is the end product? You'll get chips, potato chips, right? Or some people call it as potato wafers. Understood what is wafers? The same thing we are also doing. We are taking the silicon ingot here. We are slicing it into silicon wafers. So this is called as silicon wafer. Now you have the complete silicon wafer, right? Now in on this silicon, devices are fabricated, right? So on this silicon, devices are fabricated. Now what are those devices? What does devices means here? Devices means transistors. Now transistors can be fabricated on the silicon wafers using different technologies, using different logic. So there are different kind of FETs, right? So basically we will use MOSFETs. Nowadays we are having FinFETs, right? So MOSFET logic is majorly used to fabricate in wafer. Now we also have CMOS logic, right? CMOS means complementary of N MOSFET and P MOSFET, right? Now silicon is pure, right? It is a pure silicon. There are no impurities. It is a pure silicon. Then how we will get that conductivity benefit? How conduction happens? Now we need to understand the material also, right? Material is silicon wafer. So how conduction will happen? Conduction will only happen if you have a electron hole pair generation, right? But this is already in a stable state, right? How you will get electron hole pair generation? We need to add impurities, right? That is called as doping, right? Doping with what? Doping with either trivalent atom or pentavalent atom, right? If you dope it with trivalent atom, you will get whole majority, right? If you dope it with pentavalent atoms, you will get what? Extra electron, means electron majority material, right? So this is called as N type. This is called as P type. Clear? Now, now during the fabrication process itself, so some part of region will be doped, some part of region will be doped with pentavalent, some part will be doped with trivalent. In that way, devices will be fabricated. When we say device, it is a MOSFET. So I'm drawing here the cross-sectional view of MOSFET. So this is N plus. N plus means what? So it is highly doped with what? Pentavalent atom. That is why I am writing plus. So P means what? P type. Why I am not here writing plus or minus here? Because, can anyone tell me? Okay, can anyone tell me silicon is by default it is N type or P type? Your silicon, is it N type? It is acting as N type or P type? So answer is it acts like a P type. We will understand when we start advanced session. I will make you understand why it is always P type, why not N type. Okay. Now, if you see, this P type material is nothing but this default silicon wafer. Now what you have to do? You have to etch this part. Etch means, so there is a process called as etching process in fabrication. So you have to dig out this part and then you add the impurities such that you get what? N-type material here. Now you also need to add silicon dioxide, right? And then on top of it, polysilicon. Now these are what? Metal connects. So we don't know which one is source. Let's say we'll add something source, drain, and this is gate. Now this will be connected to metal layers, right? So this is how, so this is, so till this part, it is in the silicon wafer device level. After this, you have a metal interconnects, right? So metal is also fabricated here on the silicon wafer, right? Devices. So it is, so if you say this is a silicon wafer, so from the bottom onwards, you will have device level. So all devices will be there. On top of devices, you will have interconnects, right? Now, how many devices? There can be billions of devices, right? Billions of transistor means billions of MOSFET. Clear? Now, when we say MOSFET, now you might have heard this term called as tech node, technology node, right? What is technology node? What is technology node? When we say 28 nanometer, 14 nanometer, or 5 nanometer. What does this mean? Anyone? You might have heard many times, right? Nowadays there are semicon submits, right? Semicon, what happens? You might have heard we are developing, so you might have heard that the Snapdragon chip, it is in 14 nanometer, 28 nanometer. Samsung chips, Exonis, it is in 3 nanometer. What does this mean? Anyone? When we say size of chip, is it a size of chip? Is it true? No, it is not a size of chip. So it is basically, it is the channel length, right? Channel length of MOSFET. So this length is nothing but called as technology node, the channel length of the MOSFET, right? So you will have channel here, so which is called as technology node, right? So what is the difference here? You might have heard or might have read about Moore's law. What does Moore's law states? Anyone? What does Moore's law states? Yes, size of transistor, but you have to be very specific that it is the channel length of transistor. Yes, what does Moore's law state? Have you heard Moore's law? You haven't studied Moore's law? For every 2 years, doubling transistor. That is correct, right? So that's what Moore's law state. For every 2 year, transistor count will be doubling. Doubling means what? How it will double? It will. It is not a magic, right? So you have this much amount of area, right? Now suddenly, earlier you are adding, you are fabricating 100 transistors. Now how you can fabricate 200 transistor? How it is possible? Area is same, right? It is only possible if technology node shrinks, if it becomes half of what is this one, right? Earlier you are using 28 nanometer. Now you are using 14 nanometer. What happened? Technology node is shrink by half. Now definitely you can double the count of transistor or not in the same area. Yes, that is correct. Now if you go by 5 nanometer, in the same area, now you can increase by 3 times of transistor count. Instead of 200, you can increase to 600 transistors. You can fabricate 600 transistor here. Now what is the advantage here between fabricating 100 transistor, 200 transistor or 600 transistor in the same area? What is the advantage here? More the number of transistor means you can accommodate more complexity in that particular area. What does this mean? So you might have heard, right? Now you are having what? Um, Earlier you were having 2 GB RAM phones. Next you were having 4 GB RAM phones. So now nowadays we are seeing 6 GB RAM phones. Then 12 GB RAM phones are also available. Now hard disk, right? So now inbuilt hard disk, internal hard disk, right? That is also increased. Earlier we were having like 64 GB. Before that we were having like something 32 GB, right? Now we are having what, 128 GB, 256 GB, 512 GB. What does this mean, right? What is the difference between this GB? It means transistor count is different, right? So possibly if you want to design a memory for 64 GB, you will be requiring less number of transistor. Let's say for an example 100x. What about here? For 128 GB, you might require 200x of transistor. So area is same. Area is not changing, right? For 256 GB, you will be requiring what? 300x transistors, right? What is happening? More the complexity of design means 128 GB is what? higher number, right? It requires more memory elements. So what are the memory elements? Is it flip-flop or combinational cell? It is a flip-flop. You have to use flip-flop, basically T flip-flop, right? Now, how many transistors? So it will make some difficult to answer. Okay, so can you tell me how many logics are there in D flip-flop? Or let me make it simple. So you might have seen mux, right? 2 is to 1 mux, right? How many pins are there in 2 is to 1 mux? How many input pins and how many output pins? Yes, everyone. How many input pins and how many output pins are there in mux? 2 is to 1 mux. At least you should know this, right? Have you heard 2 is to 1 mux? Hmm. 2 is to 1 mux you have heard or not? Means you have read or not? Hmm. Yes, that is correct. Hmm. What about others? So it is not two inputs and one output. Total there are three inputs, right? And one output. So one is select line. Now, can you tell me that how many combinational cells are required to design 2 is to 1 mux? How many combinational cells are required to design 2 is to 1 mux? How many combo cells? We don't require flip-flop, right, to design a mux. You might have studied in digital topic. Try to recall and let me know how many AND logic, OR logic, inverter or XOR, whatever, what logic is required and what is the count of that logic. Don't know? Okay. Simple, right? So if you use two AND, one OR, and you use one NOT, because what is output? Output is I0, S0 bar, I1, S0, right? This is the Boolean expression for 2 is to 1 mux, right? This will be connected like this in this way. This is the select line, I0, I1, Y. So how many combo logics? 4 combo logics are required, right? Out of which one inverter, two and one OR. Understood? Now, can you tell me how many transistors are required? See, in the end, what is the product? In the end, your design is constructed or fabricated because of transistors only. These are all symbolic representation. This is not physical representation, right? When symbolic or what we say, these are logical representation. This is not our end product. End product is always what? Physical, right? Physical design. Before physical design, everything is like imagination, logical. It is not present in real aspect. Once we touch the physical aspect of design, lot of different challenges comes into play, right? So now can you tell me how many number of transistors are required for 2 cross 1 mux? How we will decide? So basically, if you say, if you see inverter, how many transistors are required to design an inverter? How many transistors to design an inverter? Correct. So we require two transistor. Why two transistor? If we are using CMOS logic, right? If you're following CMOS logic, what CMOS logic says? Complementing PMOS network and NMOS network, right? So this is pull up transistor, this is pull down transistor. We'll connect something like, so this is input, this is output, supply, ground, right? Now this is complementing each other, PMOS and PMOS network. This is not PMOS, PMOS network. Now if you use one PMOS here and one NMOS here, right? So what will happen? It will complement the input. You give 0, you will get 1. You give 1, you will get 0, right? So that is called as CMOS logic, CMOS inverter logic. So how many transistors are required? Two transistors, one PMOS, one NMOS, right? Similarly, how many transistors are required for AND, right? Using CMOS logic only, right? How many? So here we are having y is a bar. How many transistors are required for AND? Applying the same logic, can you tell me answer for AND? 10 transistors, 6 transistors, 4 transistors. So answer is 6 transistor. That is correct, not 4 transistor. Why 6 transistor? Because like I said, CMOS is what? Complementing, right? Whatever your MOSFET is, it is complementing. So what you have said 4, that is correct if there was no complementing, right? So, so if you use 4 transistor, right? 2 PMOS here and 2 NMOS here, right? This is what? This is NAND, right? If you use 4 transistor, this is what? NAND. We need to complement it. If you complement, then only you will get what? And, right? Complement of NAND is and. Now you have to add one more inverter. Inverter has 2 more transistor. So total 6 transistor. Similarly for OR also we have 6 transistor. So total how much? For AND 12 transistor, 2 and 2 transistor, 1 or 6 transistor. Add up and tell me what is the total number? Total is 20 transistors, right? 20 transistors are required to be fabricated on silicon wafer, right? So not everywhere. So small section it will use 20 transistors for 1 2 is to 1 mux, right? Now think about this like this. So for single bit memory, right? 1 bit memory, right? Or 4-bit memory or 8-bit memory. How many transistors are required? For 1-bit memory, how many transistors are required? You can check, means even if you do not know, it's okay. So you can check, let's say x number of transistors are required for 1-bit transistor. How many it will be required for 1024 bits? 1024 bits means what? It is, so how many bits are there in bytes? So this is bytes, let's say this is bytes, right? So you can go through, I will not discuss more on that. So you can see that for this definitely you will require multiplied by x amount, right? It means transistor count will increase drastically, right, in the same area. So if your design complexity increases, right, the transistor demand or count will also increase. Now, how to overcome this? That is the reason in earlier days, like say 5 years back or 10 years back, you were not seeing phones with 128 GB, 256 GB, 512 GB. You are not seeing phones with what phones? Even in laptop also you won't find 12 GB RAM. in earlier days. So we have Intel, right? Intel Pentium 4, dual core. These were old processors, Pentium 3. So these cannot accommodate 12 GB RAM, more than 12 GB RAM. It cannot operate, right? Why? Because complexity is less. Processor complexity. Now, how they are able to accommodate more complexity in design? Because technology node has been shrinked from higher tech to now. We are recently working on 1.5 nanometer, 2 nanometers, 3 nanometers also. This is the latest one. Now in market, if you see phones, right, they are having the smallest transistor, the chips. We are having phones with 3 nanometer from Exonis, from Snapdragon, right? So there are multiple number of chips are there. Okay, that is the reason you are able to get 128 GB RAM, 256 GB RAM, memory, right? RAM you are getting 6 GB and more than 6 GB RAM, right? That is the reason you are getting more complex design for this chip. Now, when we say this nano scale, right? This is a what we are trying to learn here. Basically, it is a nanotechnology, nanotech, right? When we say a nanoscale, nanometer, what do you understand by nanometer? It is 10 to the power minus 9. It is in this scale, right? 10 to the power minus 9 scale. So how small is this? Can anyone tell me how small you can imagine? How small is this? Yes, Hitesh, that is correct. You can modify the design and then that can be reduced to 10 transistor. I was telling just at least if we go by CMOS logic, we can have 20 transistors. Of course, the design can be optimized. So when design is optimized, it is called as custom design. In that case, we will discuss when we will be working on PD advanced session. Yes, how small? So what is the size of coronavirus? Anyone? You can check in Google or something and let me know what is the size of coronavirus. Can you check and tell me what is the size of COVID coronavirus? Just check in Google or something, right? Is what is the size? 140 nanometer, right? So that is the latest variant. So it is between 140 nanometer to 200 nanometer if you check, right? Based upon different variants. So you can see 140 nanometer is a huge number compared to on which we are working on in the recently in the company. Even here in institute also we have 28 nanometer and 14 nanometer designs, right? So which is very small compared to this or not? How many times small? If we take 14 nanometer, it is 10 times smaller than coronavirus, right? It is what? 10 times smaller than coronavirus. Can you see coronavirus from your naked eye? No, right? We cannot see coronavirus from our naked eye. Even from the normal microscope also it is not visible. Micro means what? Micro levels scope, right? You have to go into nanoscope, not microscope. Then only you can see coronavirus, right? So understand something like this, that we are working on something, some design, some circuit design, right? Very complex design in nanoscale, which is not having the visibility for humans. Now, how to work, how to design? You cannot use pen and paper and pencil, right? For that reason only, we have you have to understand how to work in EDA tools, right? Electronic design automation tool. That is what I was explaining. What is the importance of EDA tool here? Now we have different types of EDA tools available in this institute. Okay. Now what are those? So we have we have ICC2 from Synopsys. We have design compiler from which is used for synthesis. ICC2 will be used for floor plan placement, CTS and routing. We have Fusion compiler, ICV, prime time and star RC. From Cadence we have Genus, Innovus, Tempus and PVS. Right? These are the tools which are available in our institute. Okay. Now, when theory session will happen? Theory session will happen on every weekends, right? So there will be timing something like 9:30 to 12:30 or 10 a.m. to 1 p.m. on Saturday and Sunday. And lab session will be on 2 p.m. to 5 p.m. Now, there are people who are working on IT sector or they don't have time to visit to institute. So they can opt for online sessions or online live sessions, right? So in online session, what will happen? You can attend weekend batch. You don't have to attend weekdays. So for weekend batch, for working people, we have weekend batches. Like the theory session and lab session both will be conducted on these weekends. So first half will be for theory, second half will be for lab. After completing the course, right? If you have completed the course very seriously, you have attended all the classes, so you have a good attendance, right? You have completed all your assignments which are given to you in live classes, and in the assignment book also we will provide one assignment book. In that you will find around 300 questions. You have to solve those questions so that you will get practice to those questions to attend written exams or interviews, right? So the structure we are following here is, so regular tests and assignments will be given, which will help us and which will help you also to track your progress, right? And regular hands-on problem and solving exercise will be given to you in your lab session, so that you get habituated and you get a hands-on on the EDA tools. So whatever EDA tools I have mentioned, these EDA tools are industry level tools which is used in industry. These are all licensed tool. It won't be available for free of cost, right? These licenses are very costly. Okay. So if you get that real time hands-on on industry level tool, that will be definitely give you an extra edge over the other people who are trying to get inside the VLSI industry. Okay. Regular mock interviews will be given, right? Why mock interviews? Once you have completed the course, so some people are having a good knowledge on the subject, but somehow they lack in communication. They are not able to express their answers. So this mock interview will help you to cover those gaps, right? Where you are missing, what are your weak points. So those feedbacks will be regularly given so that you can improve your interview skills, right? And regular resume building and soft skill session will also be given to you so that you can improve your soft skills parts. So apart from this, any questions you have regarding any guidance, you can always be welcome to the there is a managing team here in the ground floor. You can always visit there and you can discuss your problem issue. Sometimes some people are slow learner, they will take some extra time, they will need some extra classes, right? So sometimes we will arrange that also if you are lacking something, right? With if you are missing any class, that is not our problem, right? You have to attend all classes, but still you are saying that okay, I haven't understood this xyz concept, right? I need some understanding on that. So in that case also we will provide that help, right? So what is the placement process here? First, complete all your course, attend all the session, have a good attendance, complete all your labs and lab assignment, project which is allotted to you, that project design, you should take it till the routing stage, it should be completed. Clear all the internal test which is given to you, right? You have to get a good score in that. Mock interviews you should clear, right? then then we will give you interview preparation session, and in the end appear for interviews with hiring partners, right? So we have lot of companies, there are different companies, different level of companies, there are product companies, there are EDA companies, there are service based companies also, right? So those support will be given in the when you have completed the course, right? There lot of opportunities will be coming up which on which we will be providing the application link for that, so that you can apply in multiple number of companies. Based upon your performance in interview, you will be getting shortlisted, right, for the next round. Okay, any doubts here? So this is how we are going to follow. If you have any question here till this in the course structure, you can ask, or else I'll start with the what is VLSI flow technical part. This is the non-technical part which I have discussed here. Any queries regarding course structure, timing, recorded videos, anything related to course? If you have doubt, you can ask me in chat box or directly also. No, there is, we cannot see, we cannot say that Fusion compiler will replace all other, right? All the tools which I have mentioned, right? All tools has its own merits and demerits, right? Like ICC2 cannot be used for all the operations. FC cannot be used for all the task, right? So like if you say Innovus is more better for floor planning, ICC2 is better for PNR, right? So it depends. It's not like something is bad or something is good. All tools are almost same. Only thing is that GUI is different and some commands are different. That is the only difference. If you master or learn any one of these tools, you can learn any tool. It is quite similar. Is any other question regarding course structure? Okay, then we will move to next. Now let us discuss few. I will give some briefing on VLSI. Right, already I have started this. So what is chip fabrication and what is chip designing? Okay, first any design is any hardware design, right? It happens in EDA tool, and it is designed by designers, right, or in design engineers. So designing the architecture, logic, and ICs, all these are part of design, right? What it does, it is a who does it in which companies. So there's those companies are called as fabless company, the companies which does not have its own fabrication, like Qualcomm, AMD, Nvidia, right? What are all fabrication based company? TSMC, Taiwan Semiconductor, US UMC, right? Intel, Samsung, these all have its own foundry, right? What are the tools which is used? EDA, I have already discussed. ICC2, Innovus, Fusion compiler. What is the process? It starts with RTL coding, that is called as Verilog design, right? RTL Verilog coding is Verilog is used, or VHDL is used to design a hardware. Next is synthesis, and then till synthesis it is all logical. After that it is physical implementation of the design, and then you have to verify that physical design, right? So from physical design onwards, it is all physical implementation of design. Then exporting the GDS2 layout files, which needs to send to foundries for fabrication. Okay. So once your design is complete, physical design is complete, GDS2 files, GDS2 layout files will be exported to foundries. Now designers rely on this foundries manufacturing chip layout, right? Once this design is completed, it will be sent to the foundry. This is how it is followed. Now this is the output of a designer, right? Or design, right? This is not the end product. End product is what I have told, right? It is on the silicon wafer, that particular chip, right? This is not the end product. This is the designer's end product. So designer's end product is called as GDS2. It is a graphic data system, right? It is a interactive information. Now what information consists in this GDS2? So it consists of layout information, right? Physical layout information. When we say physical layout, what does this mean? Slides are in presentation mode, right? Could you share the list of companies from which we can expect to get offers and completion? See, we cannot provide the exact list because the opportunities, Hitesh, it comes based upon the requirement. Suppose currently now Wipro is requiring some 100 students, right? 50 or 100 candidates they require. But that is not available always, right? See, now they require. Maybe after 2 months they won't require because they have already hired. That time that company won't be there. So how we can give that exact list? Because after 6 months the company's requirement might be different, right? Currently there will be some XYZ company which will be requiring right now, but after 6 months they might not require. So at that time there will be different list of companies, right? That is how it works. Okay. So when I'm saying layout, right? Layout means what? Layout means what? It has diffusion layer, it has polysilicon layer, it has metal layer, right? All these are what? Physical layers, right? Which will be fabricated on silicon wafer. So let us discuss ASIC design flow here. What is ASIC? What is ASIC? What is ASIC? It is an application specific integrated circuit, right? When we say application specific, means the design which is only dedicated to application, right? What does this mean? Yes, it is application specific. So can you tell me what all applications you see in day-to-day life which consist semiconductor chip? Can you give me some application which you see in day-to-day life? Can you write in chat box? Yes, so there are many applications like washing machine, mobiles, laptop, AC, refrigerator, right? Fridge. So you name it. Cars. Nowadays we are having what? ADAS system. Nowadays we are having ADAS system, right? Okay. What else? Many are there. Many applications, even in medical, right? Medical applications. There are a lot of medical application. Then, so in laser surgery, right? The machines which are used in laser surgery, they will use semiconductor chips. Military, right? Or defense, we will say. In defense, missiles, aircrafts, navy ships, right? Nowadays, all these are using semiconductor devices, right? Semiconductor chips. Without semiconductor chips, nowadays there are no applications, almost no applications, right? So now what is happening? You can fabricate or you can design chips which are dedicated to application. Now if you design a chip which is meant for washing machine, whether it will work in AC, no, right? It is specific to washing machine only, right? After this much amount of time, water must be released. After this much amount of time, it should wash the clothes, right? So the control system which is given to this chip, it is completely dedicated to washing machine. The hardware designed is completely dependent on the application. Now, application requirement of washing machine. How much memory is required for this chip, for the washing machine chip? Whether it requires 128 GB, whether it requires 128 GB of memory in washing machine chip, no, right? We don't require 128 GB in washing machine, right? So that is the reason I'm calling it as application specific. Maybe it is require what? Less than, let's say 1 MB, right? It is very less. Less number of means memory requirement is very less in washing machine chips. Clear, everyone? Any queries? Okay. Now the transistors are integrated in those silicon wafers to get the design. Okay. Now what is ASIC design flow? How design cycle works? What is the first stage? First stage starts from the specification. Like I said, how much, what is specification? Specification is basically with respect to power, time, and area. So suppose you want to design a washing machine chip. How much power that chip requires? Definitely low power only, right? We don't require a power which is required for laptop, right? It requires very less power. So it is a low power design. What about time? Means whether that chip should be very fast. So you are using laptops and mobile phone, right? What is the clock frequency which is used? 2.4 gigahertz, right? More than 2.4 gigahertz, 2.1 gigahertz. So it is in gigahertz. Whether that much of faster chips are required in washing machine chip? Possibly not. We don't require that much of speed in the washing machine chip. What about area? Do we require a big, huge amount of area while designing washing machine? No. So that is also not required. All these question comes under specification to decide the what is the memory requirement, specification only. So once it is decided what we are designing, right, what type of washing machine we are trying to design, what kind of control it should have, that will lead you to the architectural design, right? Now suppose, do we require a display, right? Do we require a display panel on washing machine? Yes, in some washing machine they will require display panel also, right? If you are having the display panel which is touching, which is also having touch feature, then definitely in your architectural design you should also keep a display module, right? Display module. Suppose in your chip for washing machine design you want to create a speaker kind of thing, like it should say that your clothes are washed, it's completed, so it should have speaker module for processing, right? So you are giving some time and it will require to calculate something, you will require what? ALU modules also, ALU subsystem also, arithmetic logic unit. Definitely some amount of memory is required. Suppose if power cut is there, right, you have started the washing machine and power cut is there, what will happen when power comes back? Again it should restart from the same zero? No, right? It will be waste of water and waste of washing powder. So it should be stopping there. You should keep the last data in the memory. Once power is back, it will start from the same time, same position without wasting water and washing powder. That is why memory is also important in washing machine design chip. Whether mic is required, I don't think mic is required in washing machine design chip. Bluetooth, yes, nowadays you can also have Bluetooth in washing machine so that you can operate your washing machine from your mobile phones, right? Wi-Fi also same thing. So these are some subsystems which will be required based on your application. So these are what? Part of architectural design, architectural level design. It is nothing but deciding the specification that will lead to your architecture. It is nothing but a block diagram. It is not the actual circuit. What all blocks are required. Once blocks are decided, I need one ALU, one display module, one PL, one memory. Now each subsystem needs to be designed using Verilog code, which is called as RTL designing. How many of you know the Verilog or VHDL code? Can I get the response? How many of you knows Verilog or VHDL? Okay, two. I get a two hands. Anyone, any more? So others, I assume no, you do not know Verilog code. So basically, this is not a normal coding language, right? Which you have learned in C, C++, Java, or software programming language. Verilog codes are called as hardware description language, HDL language, which is used to describe hardware, right? It is not a software. Don't just uh, confuse with the software languages. It is a hardware description language which is used to define logics, right? Using this Verilog code, now you can design marks, what all combinational cells required in the subsystem. All these can be designed logically. Whether any physical information is present in this design? No, right? All are logical information only. Whether there is any height or width of design? No, there are no physical information, right? Once logical design is ready, you have created a logical design, then you should verify it, right? Whether the design is functionally correct or not, whether design is logically correct or not. For that reason, we have another domain called as design verification. For the possible stimulus or the possible test cases, it will test the design, right, for its functionality coverage or logical correctness, right? Once this is passed, then we will say that your design is verified, it is logically working fine, functionally it is having a good coverage. Once logical and functionality is checked of your design, then it will move to synthesis stage. Now, what is synthesis stage? So synthesis usually converts your RTL code into gate level netlist using standard cells, right? Why we need to convert from RTL code to gate level netlist using standard cell? RTL code, as I said, there is no physical information. If there is no physical information, how you will start physical design? Not possible, right? That is the synthesis stage where you need to include technology node, right? Before synthesis, everything designing part is technology independent design. After synthesis or from synthesis onwards, it is technology dependent format. So basically it converts technology independent design, non-physical design, to physical uh, related design, physical parameter related design, right? Which is technology dependent. So this stage ensures that design meets timing, area, and power constraint after the conversion. Okay, it is a translation, right? It is basically a translation of logical design into a technology dependent netlist, right? If you see, here is small example. You can see for and, you can write like this, and to, or inverter. What are these? These are the library names which is technology dependent. So once that is completed, right, or during synthesis, we can insert DFT module also. DFT is basically designed for testability, which ensure the chip which can efficiently tested after manufacturing. See, once you have designed a chip, and how you are going to check the design which is having billions of transistor, which is in nanoscale, if there is some wire default is there, right, which is having wrong data in that particular net, how you will identify? It's very difficult. You cannot dig down to which net is having problem. That is the reason we'll insert a DFT logic. So it is like a, so you might have seen one movie, right? The movie is Iron Man movie, right? In that there is one scene. So usually that person, the character, will always communicate with one guy that is called as Jarvis, right? He will call it as Jarvis. So in one of the scene, there is one character called as Ant Man that goes inside the Iron Man suit, right? What happens then? So he tells the Jarvis that there is some default. He is plugging off all the connections of that suit, right? What to do? So immediately that is, the system is tested, right? How much damage happened, right? And it tells that these are the damage, and on these parts of the suit or the system is having the damage, and then only you can apply the fixes to the damage or not. So if that facility was not there, the automated testing facility is not there, then he should be opening all his suit and then checking out where, what is the problem. It will take a lot of time. That is why DFT is included. So basically there are ATPG generators, there are MBIST memory built-in self-test kind of logics which is inserted through DFT. Okay, so after this stage, this is called as back end stage, right? So till now whatever we have discussed, it is front end, right? All logical part is in front end. Now when physical implementation start, we call it as back end stage. So the first stage in physical design is floor plan, where we create die, we place all ports, we create voltage area. If we are working on multiple voltage design, we have to create separate voltage islands, right? We have to place memories, right? Then there are some physical cells which needs to be placed here, right? You have to create blockages also, right? Why? What is blockages? Blockages means if you apply some a region of blockage, right, there will be no cells which will be placed in that region. Then definitely you need to give power to all these cells or not, memories, standard cells. So the power management is also very important. That is called as power planning. How you are going to give the supply without increasing the IR drop, right? So if it is a long, suppose in your room, uh, so you in your bedroom, right, where you are going to keep the socket to charge your phone near to your bed, or you will keep the socket near to your main door, no, right? That will increase the wire length. The next step is placement, where we place all the standard cell on the standard rows. This also will understand more in detail in the advanced session. Okay. After this, you need to route it through the clock because there will be a lot of sequential cells in your design. You need to clock it strategically in a smart way, right? If you're making clock tree structure and connecting all your sequential cell directly from ports to these cells, what will happen? It will require a lot of nets, right? That is not good for your design. If you see the second part, here also we are routing clocks to all the cells, but in a structured manner, in a tree-like structure. So this is the main trunk, and then we have multiple branches. So it is basically H tree. It is called as H tree algorithm. If you see here, it looks like H. So this helps us to reduce number of clock nets. It helps us to reduce the latency. I mean the it reduces the longer path, right? It also reduces the skew in the design, right? Of course, the many terminologies will be new to you. You won't be understanding. We will discuss when we are in advanced session, right? So it usually minimizes the skew and insertion delay. Then finally, once you have done power routing, right? Power is supplied. Clock is also supplied. In the end, we are going to do signal routing for our design. Signal means the data signal. There will be some bus D0 to D11, right? So there will be data buses, data signals. How those will be routed? Routed through signal routing. In the end, we have sign off. There are three sign offs which we are going to follow: timing sign off, power sign off, and physical verification. So basically, there are three sign off, right? In power sign off, basically, there will be IR check, static as well as dynamic IR check is there. In physical sign off, we will be checking the DRCs, LVS, and we will also have CLP, FVCLP. FVCLP is nothing but logical equivalence check as well as conformal low power checks. All these are checks which is part of sign off. Once these all sign off checks are given the green flag to your design, then you can generate the GDH2 file which can be sent to the fabrication lab, right? So these are the respective tools which will be used for the respective stages. So for STA, we are going to follow prime time. For PNR, ICC2. For synthesis, design compiler. So for physical verification, we have ICV, right? So these all comes under back and flow, right? So this is the summary of advanced physical design flow: floor planning, power planning, CTS placement, and routing, and in the end sign off. So we have completed this demo session here. If you have any queries, you can ask me. So there will be EDA tool access, right? So many people will have this question whether till what time you will be having EDA tool access. EDA tool access will be provided throughout your advanced session. It means you will have access for 4 months. That is 24 by 7. 24 hours. You can use it anytime, anywhere. So we'll be providing you VPN also so that you can use from remote area. Yes, if you have any question regarding course or placement or the course structure, you can ask me. I wanted to know about the placement policy. Will it be based on bond agreement or bond free? Um, See, basically, if you go in any company, right? Let me clear this. Let me share the screen. It is a good question. So many people will have this doubt. So regarding bond, right? Yes. So you go into any company, any VLSI company, there will be bond from 2 years to, in some companies, 4 years also, right? And if you break the bond, then you have to pay some amount. So how much? It also depends, varying from 2 lakhs to 7 lakhs if you break the bond, right? So they will usually take bond on stamp paper or something like this to make it more strong, right? Uh, yeah, so basically all the companies, for freshers I'm telling, not for experienced person. So for freshers you have to sign the bond. So from company to company, it varies between 2 to 4 years. And if you break it, you have to pay this amount and then you are fine to exit the company. Is it clear? Have I answered your question, Hitesh? This is only related to bond agreement. So one more thing will happen. So they will also provide some internal training, maybe for 3 months to 6 months. They will provide you some training. They will make you ready for the client location. Client location means what? So in the client location, what are those clients? So, like Samsung, Qualcomm, Intel, Google. There are many product clients, right? So they will make you ready such that you can work in this client location. So in this client location, you will be going into this client location and you will be working on multiple projects in the latest live projects directly, right? That is how they will prepare you. Product companies, they do not hire usually for off campus unless and until you have a tier 1 college background, IIT or NIT, right? So in that case, product companies will give you opportunity. Otherwise, they do not hire people from tier 2 or tier 3 colleges. Product means what? Samsung, Qualcomm, Intel, Google, AMD, AMD, right? There are many product companies, but more than product companies, into 10, right? Whatever count is here, right? Or will not, 10 is a big number, into 5 we'll say. So how many product companies are there? Multiplied by 5 approximately, there is a count for service based company, right? Clear, everyone? Okay. Yeah, any other question? If you have any other question, you can ask me. In this course, we have access to use the tool Fusion Compiler. Yeah, FC will be provided based on request only. So you have to check with the management on that. So the lab session will be conducted on Synopsys ICC2, and then Innovus support will also be given. Synopsys ICC2. Synopsys ICC2, you will be performing project on 28 nanometer, 14 nanometer. We also currently have 5 nanometer, but setup is going on, so it will take some time. Okay. So on this technology node, you will be having hands-on using Synopsys IC2. So floor plan and PNR. Then sign off, you will be having hands-on on industry level Synopsys prime time tool, right? Then for RC extraction, we are using star RC. For synthesis, you will be performing hands-on using design compiler. Okay. Any other question? Sir, I have completed masters from IIT KGP. Sir, is it possible after completion of course, could you connect me with the product-based companies? Yeah, I think you have a good opportunity. I mean, good scope. Yeah, you can. We can talk on this. So you have done masters in what? VLSI design or different domain? What is your special? What was your specialization? That is also important. Communication and signal processing. So it is not VLSI, right? Okay. Micro. So usually it is called as microelectronics specialization. Okay, it is also fine. I think it will work. Yeah. So you have a good chance. Yes, sir, I am working in hardware testing with 5 years of technical. What is your hardware? Means what kind of hardware testing? Can you elaborate, Gautam? See, hardware testing means it's a huge, right? What you are doing? You are doing PCB testing. You are doing signal testing, in online testing. So there are multiple things. In railways also we have hardware testing, right? So you have to be specific here. Board level and functional testing. So yeah, PCB, see, like I explained here, right? VLSI means what? We are working on nanotechnology. It is in nanoscale, 10 to the power minus 9, which you cannot see from your naked eye. What about PCB? PCB, each and every connection or net you can see from your eyes or not. It is big, it is not comparable itself. right? PCB's board works on which voltage? 5 voltage, more than 5 voltage. Now I'm telling, right? But the nanoscale designs works in very low voltage, 0.9 voltage, 0.5 voltage, 0.65 voltage, right? It is a big difference. So in physical design, you will have more challenges when you are working in nanoscale. It is not similar what you were testing in PCB, because you will be checking connectivity related. You will be checking that 90-degree turn is there or not, how we are going to do, what is the loss, breakage is not there. So it is not that kind of testing which we do in physical design, because when you are working in nanoscale, you have hundreds of problems there. Some are material level, some are logical level, some are like power level, right? Some are timing related issues. There are many issues. So right now I got one offer from one service based company, but the bond duration is long, amount is also high. Okay. So usually they will keep all these parameters, right? Because they make profit and they want to be sure that you will be staying for some amount of time. And that is the reason they will keep the bond. It's okay, means you can apply for other companies also if it does not suits, right? So how many years they are telling? Like, is it 7 years? Then it is very huge. 7 or 5 years is very long time. You should not go for that kind of bond. In which month we can expect the placement process? So you can calculate Prati, starting from the basics, which is 2.5 months, then comes 4 months, 4 to 5 months, let's say. So overall, let's say you can assume, I mean, you can calculate and approximately you can say that it is 6 to 7 months. So if you start from this session, means, I mean, this batch. So after 6 to 7 months, you will start getting the placement opportunities. Sir, if the marks are less than 60% in 12th, there will be problem for placement. No, 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 of course not. What is your name? I don't know. You have written 3 letters. So of course not. You won't have any issues with the percentage, right? You get, even if you get a 50% or 55%, it is fine. But thing is, of course, the opportunity wise will be less for you. You won't get much opportunity because people who are from non-tech, right? So they will be shortlisting your resume first based upon your percentage only. They don't know how much you know or not know. So there, in this place you might get somewhat demerit, but it's not like there is a hard rule that you have to score 70%, 80%. No, it is not there, right? So at least you should be like 50 to 60% should be there. It is fine. In lot of company you will be eligible. Lot of service companies, you have a good opportunity. Okay, 3 years. I think 3 years is fine. So basically, like I said, any company will have the bond for 2 years at least. I'm saying max 7 years, 5 to 7 years. I've seen some companies also take bond for 5 to 7 years. So 2 and 3, I think it is fine because during that period you will be in learning stage only. You'll be learning a lot of new things. With 22 lakhs bond, it is huge, right? Which is 2 times of package they are offering. No, that is huge. You should not join them. 22 lakhs is very huge. What if some emergency comes and you want to leave the job? It is a very huge amount. No, it's not good. You can negotiate with the management that, see, max you can say that 5 is good. 5 lakhs bond breakage is good, but 22 is huge number. Yeah, any other question? Hitesh, you can take my number from the management and you can connect with me if you have any other queries also. Yeah, any other question regarding course, batch, when batch will start? You can when batch will start, you can check from the management, right? They will tell you regarding when batch is scheduled. Any other questions related to placement? So I hope everyone is having. So when is your pass out year? Can you just mention in chat box what is your pass out year? You are a recent pass out, or so some said they are in final year and some said second year also. I think second year won't be eligible for job, right? Even if you learn 2026. Okay, recent pass out. Recent pass out is fine. Okay, 2023. Good. Okay, 2026. 26. 2022 MTech working in IT. Ah, it is fine. Mujahid. That is also fine. So those who are like 2026, right? They are having good scope in MNCs like Wipro, Infosys. 2018 BTech. Yeah, it is 2018 means 6, 7, 8 years. Okay, you are working in IT for 8 years. It is fine. This is also good. Yeah. Anything? Any other questions? Okay, then I hope I have answered all the question. Right? If you have any queries, you can ask me or you can ask the management also. Okay. So we'll stop here. Thank you everyone for joining the session. I hope everyone liked my session and willing to enroll this course. Thank you everyone.